Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Assalamu alaikum little kids. This is Sheikh Conceptual and today we are going to discuss chapter number 16, Introductory Electronics. And now we are going to discuss the exercise of it. All conceptual questions we will discuss today. If you remember last three conceptual questions we have already done in the class, but today in today's lecture we will discuss all one by one. Please. Okay. The first conceptual question, it says that what are free electrons? You know that in an atom in the valence shell, the electrons they are having weak they are having weak nuclear forces. Now what happens when you provide little energy or small amount of energy, the electrons are ejected from the outermost surface. Okay, now those electrons behave as free electrons. Those electrons which are free from binding energy known as free electrons. For example, metals are good conductors, they are having free electrons. When you provide small amount of energy to it, so those electrons leave the metal surface, and this process is known as thermionic emission. Now, these electrons behave as what? These electrons behave as free electrons because they are free from binding energy. Now, to understand it more better, we need to understand one thing, that is work function. Work function is basically the minimum amount of energy given to a certain atom or certain electron to eject it from the valence shell or outermost shell of a gaseous atom. Do remember, it must be gaseous, right? Okay, in a gaseous atom to release it, to eject it, to remove it from the outermost surface or outermost shell. Okay, so this electron is behaving now as what? Free electrons. Okay, once again, what are free electrons? Those electrons which are free from binding energy, and if you provide certain energy to it, they leave the outermost shell. Those electrons behave as what? Free electrons. For example, in metals they behave as conductors. Okay, and they take part in conduction, right? So this is all about free electrons. This is question number 1. Now, coming towards what is the function of accelerating anode. You know, accelerating anode is one of the parts which is used in electron gun. And in electron gun, we know that there was a thermionic emission, tungsten filament, indirect heating of cathode, and electron leaving the metal surface and just coming out and passing towards different portions. For example, focusing anode, accelerating anode, and deflecting system, and then fluorescent screen, and a lot more things we have discussed already in CRO. Now, just they are asking what is the basic function of accelerating anode. So the basic function of accelerating anode is just to speed up, just to increase the kinetic energy of what? Kinetic energy of electron. We can see that just to speed up the electrons which are emitting from the tungsten filament, or you may say filament. Just to speed up those electrons, a specific portion is used, what we call accelerating anode, and it is used in electron gun, okay, which is one of the part of CRO, okay. Now let me summarize it once again. What does it say? What is the basic function of accelerating anode? Basic function of accelerating anode is just to speed up the electrons moving or flowing electrons speed, increasing. Function is what? Accelerating anode. Once again, just to increase the speed of electron which are emitted from a filament, we use a specific part of electron gun, what we call accelerating anode. Now, coming towards if the electron, third question, if the electron beam in a television tube is striking just at one point on the screen at a time, how can we get a picture on the full screen? This is very important. Now, do understand one thing. You know, on fluorescent screen, the electrons which are hitting at different points, they form sawtooth waves. Sawtooth waves are like this. These are what? These are sawtooth waves. And there are some horizontal lines also. Those horizontal lines are called rasters. Basically what happens when electron beam is moving over here like this, it sweeps on the whole screen. It sweeps on the whole screen, and over here what happens? Sawtooth waves are formed, and there are some horizontal lines over here like this. Look, these are horizontal lines. Okay, these are what? Horizontal lines, and these horizontal lines are called rasters. Basically, when electron hit the fluorescent screen, so spark produces over here, and over here basically sawtooth waves generates. Now sawtooth waves is in form of this, okay, and this wave is basically spread on the whole screen or sweep on the whole screen. That is why we see picture on the whole screen, or you may say full screen. Now what happens in color TVs? You know, in color TVs there are 3 electron guns are used with 3 basic colors: blue, red and green. Like 3 colors are coming and they are striking on the screen, okay, and a very colorful image is formed on the screen. So this is all the physics of question number 3. Coming towards question number 4, what does it say in question number 4? Why image is distorted when a magnet is brought close to an old television or monitor with cathode ray tube or CRT inside? Do remember one thing, electron beam is what? This is negatively charged particle. Now do remember, we have already discussed when electron beam is passed through electric field, it bends, it moves towards the positive plate. When the same electron beam is passed towards the magnetic field, we know that in magnetic field, north pole is considered as conventionally the positive pole of the magnet, while south is considered as conventionally the negative pole of the magnet. So when the electron beam is passed through a magnetic field, they will bend or turn towards what? They will bend or turn towards the north pole. Okay, what does it say over here? They are saying, like, if an electron beam is passed through okay. Coming towards question number 4, what does it say? It says why image is distorted when a magnet is brought close to an old television or monitor with cathode ray tube CRT inside. Okay, do remember one thing, electron beam is negatively charged particle. When this beam is passing in an electric field, it will bend towards the positive plate. When this beam of electron is passing in a magnetic field, in magnetic field, north pole is considered as conventionally the positive pole, south pole is considered as conventionally the negative pole. When the electron beam is passing in a magnetic field, it will bend towards what? It will bend towards the north pole. Okay. Now in the question they are saying that if you bring a magnet close to a old television or monitor, why the screen is distorted? What is the physics of that screen? Do you remember one thing? You know, in fluorescent screen, okay, now this is fluorescent screen, electron beam is coming and it is striking on the screen. Do you remember? If you bring a magnet close to it, for example, if I bring a magnet close to it, for example, this is north and this is south. When you bring a magnet close to it, so this north pole will repel the electron beam, and instead of hitting this point on the screen, electron beam will hit the upper point on the screen. For example, over here in the diagram you can observe. For example, if you bring the south pole over here, like this, so instead of hitting the central point, electron beam will hit the lower point. Okay, so we can say that when an electron beam is passing and we bring a magnet close to it, basically deflection of electron beam takes place. It can deflect at wrong point and it will hit the wrong point on the screen. As a result, you will see a distorted image. Okay, now what is the physics of color TV over here? You know, as I have told you earlier, that in color TV there are 3 electron guns used with 3 basic colors: red, green and blue. Okay, for example, this is red, this is green, this is blue. Okay, for example, it is hitting this point, green is hitting, for example, this point, and blue is hitting, for example, this point. Now, if you bring a magnet close to it, for example, I am bringing a magnet close to it, for example, this is north and this is south. So, wrong hitting of points happen. Like how? For example, if you bring a magnet, so this red will hit over here, for example, I say at this point, this blue will hit this point, green will hit this point, blue, green, red, blue, green, red, green, blue, red, green, blue, red, blue, red, green. Like over here, if you see, all the points are distorted. They are not regularly hitting a specific point, just they are hitting the screen at different points. Now, over here, due to wrong hitting, on the screen you are not seeing a clear image. Over here you will see a distorted image. Over here you will see what? You will see a distorted image. Now, let me summarize it once again. What does it say over here? It says when image is why an image is distorted when a magnet is brought close to an old television or monitor with CRT or cathode ray tube